Alright, so here we go with our first video on the review material. First thing is to sketch the graph and state the domain and range. So we know that our basic square root graph starts at the origin, increases to the right. So just as a reminder, square root of x minus 1 would move the graph over 1 to the right, plus 3 would move up 3, and I would still have the same shape. My domain would start at 1 and go to infinity. Remember interval notation. And my range would start at 3 and go to infinity. And that's how I would write domain and range for the problem. Next, cube root. Our basic cube root sketch. Increases to the right, decreases to the left. So again, if I want to sketch this, x plus 2 would move me left 2. Minus 1, so now the center would be at negative 2, negative 1. Same basic shape. Because it goes in both directions, both the domain and range are negative infinity to infinity. Next we have our quadratics. So first, if it's in HK form, pretty simple. I have x minus 3, so I'm going to move to the right 3. Plus 2 up 2, it opens up. And we're just talking basic sketches here without your calculator. Domain of quadratics is all real. And my range is either going to be greater than your vertex or less than your vertex. So here it will be greater than. So it will be 2 to infinity. Now, what if I have a quadratic that's not an HK form? A couple of things you can do. You can make a table, plug the values in, or can say, wait, I remember that I can just factor this, take an x out to get the zeros. So the x-intercepts would be 0 and 2. So my vertex would then be between those two at 1. So then I could plug 1 in to figure out the y value of the vertex. So if I go and plug 1 in, I have 1 squared minus 2. 1 minus 2 is negative 1, and it opens up. Again, my domain is negative infinity to infinity, and my range will be greater than the vertex. The y value of the vertex is negative 1, so I will go negative 1 to infinity. Next we have exponential. Our basic exponential curve, quick reminder, crosses the y-axis at 1 and increases left to right. So 2 to the x, and that's all I really need to do. 2 to the x crosses at 1, because anything to the 0 power is 1, and it's going to increase. Now remember, e to the x is just like 2 to the x, because it's 2.71 plus 3 would move it up 3. So instead of crossing at 1, it would cross at 4, and it still would increase left to right. Domain and range would both, the domain would be all reals. And now my range, if I think back to my first graph, my range is going to be everything above the x-axis. So now my range is going to be everything above 3. So I'm going to go 3 to infinity for my range. I'm not going to include 3, because that's actually going to be my asymptote there. So next we have our logarithmic graph. First we want to change this to exponential form. Remember, it's 2 to the y equals x. So this really turns into 2 to the y equals x, which then, if I plug 0 in for y, I get 1 for x. So I have an x-intercept, and it increases left to right. If the base is greater than 1, and it's going to decrease, it would look like that if the base was less than 1. Next, natural log of x. The only thing we have to remember is that the base is e, so this turns into e to the y equals x. Again, which e is 2.7, so it looks very similar, and it's just increasing a little faster than 2 to the y equals x. Next type of graph, we have our rational graphs. So first I just have the most basic 1 over x, which has an x-intercept which has a x-axis is the asymptote and the y-axis is my asymptote. And my branches are going to be top left, top right, and bottom left. If it looked a little more complicated, now my x equals -3 would be my vertical asymptote, x plus 3, and +2 would be my horizontal. And again, the branches would still be top right and bottom left because it's positive. In order to switch, I would need a negative sign. Last one on this page is absolute value. We remember it's the shape of a V. So I would do x minus 3 over 3 plus 1 up 1. There's my vertex. And the 2 is actually, I'm going to go up 2 and over 1 on both sides to get my V. If it were negative, the leading number, it would open down. Okay, now we need to find the restricted domain and interval notation of each. So I have in the top right hand corner to remember, you need to remember two things. Denominator cannot equal 0, and if I had a square root function, the radicand, fancy word for what's underneath the radical, has to be positive, greater than 0. So my first problem, I have a denominator that cannot equal 0, so I'm going to actually set it equal to 0 and solve. I can factor, or you can just add the 4. I'm going to factor x minus 2, x plus 2 equals 0. So x cannot be plus or minus 2. Now interval notation would say I'm going to go from negative infinity to -2, or -2 to 2, or 2 to infinity. There's my interval notation for x